Hello everyone. In this session, I'm going to talk about how are we going to use random forest for ordinal response variables. We have already looked using random forest for nominal response variables, which are the typical categorical variables, wherein we spent one session on if the categories are multiple, more than two. We also have spent a session on binary categories, where there are only two categories. Similarly, we have also looked at one session on how do I use random forest for survival data. And now I am looking at how do I use random forest if the response variable is ordinal in nature. So here I am going to look at only one single mechanism, only one single model, one single algorithm, because majorly there is not much of a difference between the survival random forest that we are using for nominal data, which is a categorical variable with multiple categories. You don't find too much of a difference, and even the package that we are talking of here is the party package. The algorithm that I am going to decide is that I am going to talk about is conditional inference ordinal random forest. We are using the same package party. The function we are using is cforest, which we have already discussed for two major activities. Right, we have used it in a multi-category kind of scenario, and we have also used the same cforest function in a survival kind of a scenario as well. So we will use the same party package with the cforest function. So we know that we can control different parameters of cforest, like we can very well set how many trees to be generated, what should be the number of variables that should be tried at for each of the forest creation, for each tree in the forest creation. So those are some of the things that we have used earlier also, and now also we can very well use the same. So looking at the data, I've taken a data called red wines, right? That is from that location. Let me quickly look at the character of this red wines. We have 1599 rows in this data and 12 columns. Looking at the summary of this particular data, I could see that I am more interested in this particular variable, the quality variable. Right now it is having values from 3 to 8. That is what I would like to convert them as factors. So I will take that as a kind of a rating. 3 means minimum, 8 means maximum. 3 is a minimum quality, low quality wine, and 8 is a high quality wine. So that is being assessed looking at the various features like fixed acidity, minimum of 4.6 to a maximum of 15.9, volatile acidity ranging from 0.12 to 1.58, the citric acid levels ranging from 0 to 1 in terms of the percentage, the residual sugar levels going up from 0.9 to 15.5, chlorides going from 0.01 to 0.61, free sulfur dioxide going from 1 to 72, total sulfur dioxide going from 6 to 289, density from 0.99 to 1, the pH ranging from 2.7 to 4, sulfates from 0.33 to 2, alcohol content from 8.4 to 14.9. So based on these things, I want to really assess the quality of this wine. This wine quality, rather than keeping it as a numerical, I want to make it as a factor. So I am making one modification. So I'll say wine dollar quality as dot factor wine dollar quality. I'm converting it into a factor variable. Okay, wine. So this got converted into a factor variable. So again, when I am looking at the summary, I should get a slightly different summary out here. Yes, there are 10 observations which are ranked 3, 18 observations which are ranked at 8. Majority of the observations I see that they are at 5, 6 and 7 locations. But I want to see if I can do the modeling of this, right? So that is what is the data all about. Now C forest, I don't think I should spend time because we have already looked at it in two different algorithms. So the only thing I will do is I'll load the party package where we will be using the C forest, and here, because this is an ordinal data, probably I can look at some performance metrics like kappas and all rather than just relying on the accuracy. So if I really want the kappa and all those things, it's better that I load even the caret package as well. So I have loaded the caret package as well. So let me look at the steps now. I have loaded the party package and the caret package. I have got the data where the response variable is an ordinal variable. Here we have taken the variable as ordinal, which is having the values from 3 to 8. I am performing a preliminary inspection on the data. That is what has forced me to convert it from a numerical variable to a factor variable. Now, the next job for me is to split the data into a training set as well as testing. I know that there are 1599 records altogether. So let me take the 70% of it. So which is around 1119. So I will take 1119 records as a part of the training data. The remaining I will take them as a part of the testing data. So I am setting a seed value of some 1000. Then creating a variable called train, which I am using a sample function. On this sample function, now I am using the values from 1 to 1599, wherein I want to pick up 1119 values randomly without any kind of replacement. So that's where I am setting replace equal to false. I am getting unique values altogether. And from here I create my training data, which is a subset of wine, which contains the rows that are there as a part of the train, and it contains all the columns. So that is what is becoming my training data. My test data is that one, which is again a subset of wine, which does not contain the values that are there as a part of the train. That's the reason I have set it as minus train, and it contains all the columns. So this is how I have split my data into a training data and a testing data. Right? Now I can get ahead into the fitting of my model. So let me just open the C forest so that I can copy the the required variables and the parameters. So I have to use the C forest function. Let me use the fit. We'll use C forest. I require the formula first. The formula for me is I need a dependent variable or the response variable. Quality is the response variable here. Tilde, I can look at all others as a explanatory variable. So that's where I am taking the dot. Data, I am taking it from my train data. I'll use it from the training data. Now, what else? I require subset, all these I will not go with. I require controls. So I'll take C forest unbiased. Right, I am taking C forest unbiased. But if I want to see what in this C forest unbiased I should go with, I don't need test stat, then test statistic, minimum criteria, save split entry is what I want to go with. Number of trees instead of a default 500, I'll go with 1000. M try also instead of a default 5, I can look at how much we have, how many variables are there in this data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 independent variables are there. So square root of 11 is 3 point something. So m try I will set it equal to 3 here. Though I can very well change it at a later point. Now the fraction of observations to draw without replacement. Right, I can very well draw 2/3 of the data approximately, but I can leave it to the default itself. So these are the two things I would like to change and based on that we are fitting the model. Okay, I need to close the bracket, looks like. So the model is fitted. Okay, it's taking some time to fit the model. Alright, let's quickly look at what is there as a part of the model. I'm typing the fit. So I could get that simple things like number of trees is this much, these are the inputs and these are the number of observations, and only that much is coming out as a part of the model, overall model summary that we are getting. Now I can very well go ahead in terms of looking at from the carrot package the accuracy of the model. Right here we have fitted the C forest model. We have said that the number of trees is 1000, which is where I can be flexible. I can change it from 1000 to something else. And the number of values that should be randomly sampled m try. Right now I have set it to 3, but I can again play around with 4 or 5 to see if my results are going to change in any way for better. Then I can very well look at the accuracy of the model. Right, 1 I can go with a confusion matrix. 2 I can very well rely on more advanced methods like kappas. Now the kappa for the C forest package, the other day also I have talked about, we can use the C forest stats. Right, if you remember, let me again quickly recollect that for you. C forest stats is the name of a function which is actually doing the evaluation of the C forest that we are getting. So I can do the C forest stats for the fitment. So what I can do is I'll do C forest stats of the fitted model, which will give me two important things out here. The C forest stats gives me two things. One, the accuracy, which is purely from coming from the confusion matrix, the percentage of observations that are correctly classified versus percentage of observations that are wrongly classified. So the accuracy is directly talking about 62.2% here, but a more advanced statistic kappa, which is again an advanced measure of accuracy of the model, we are able to see that it is only 37.84%. So the accuracy is coming out to be much lesser when I am using the kappa compared to the confusion matrix based accuracy, because here it also the kappa also considers the default behaviors that have been assigned. So by chance, what is the kind of probability that the assignment to this particular group is happening by chance? So after removing, it is calculating the probability, it is calculating the accuracy of the model. So that is the reason we will see that the kappa value slightly will be conservative, lesser, but still if that kappa value is much more higher, we can rely on our model more and more heavily compared to any others. So we can use this statistic for all these things, right? If you have any of these things, GAM formula fitted or the C forest stats, prediction functions that we have fitted, for all these things we can very well directly apply from the caret. We can apply the statistics where we can get the kappa values along with the accuracy of the model, right? So we have looked at the accuracy, we got the kappa value. Based on that, we are able to assess the accuracy of the model much more better. Then we are also looking at calculating the importance of the variable, right? Each variable, what is the importance of it? So I can simply look at var imp of the fit. If I am looking at var imp of the fit, I could see here based on the 11 variables, I want to see which variables are more and more relevant to the model. Again, the way we compute the importance, there are three different ways in which we can compute the importance. So I am showing the first of it, which is, okay, this first method that I have used is based on unconditional mean decrease in accuracy, right? The method is unconditional mean decrease in accuracy using Hapfel-Meyer approach. So based on that, right, this is what is the very importance of fitment that is coming out. So the fixed acidity is, the contribution is 0.004. It's better that I sort it, right? Let me see if I'm doing a reverse sort, is it directly coming out? I want to sort this. Okay, yeah, I think that has done the job. So the higher is the content of alcohol, 0.08. I mean, the more weightage is going for alcohol content. So the higher is the content of alcohol, the higher is the quality associated with that wine. Then next comes the sulfates, the presence of sulfates. Then the volatile acidity. The higher the volatile acidity, there is a chance that it is becoming more and more quality product. Then the total sulfur dioxide is playing an important role, and free sulfur dioxide chlorides, their impact is almost negligible when I am going with the first model for computing the variable importance, unconditional mean decrease in the accuracy using Hapfel-Meyer approach. Whereas there is another way, again unconditional mean decrease in accuracy, but I can use the Bremen approach for the same. And if I have to compute the Bremen approach, everything remaining the same, I am doing the fitment out here, wherein I have to set the pre 1.0 under 0 is equal to true. This is what I am trying to set, which will give me the Bremen approach. So based on the Bremen approach, let's see what is the level of importance that is associated to each of these variables. and we have already sorted it. Now you could see, I think the result is more or less the same. Alcohol stands the number one in terms of associating it to a high quality. Then comes the presence of sulfates, which is what is the same even in the earlier model. Then came the volatile acidity. The third position also remains the same. Total sulfur dioxide is in the fourth, which is again the same. Density is in the fifth. Citric acid is in the sixth in both of them. Fixed acidity is there in the seventh. Residual sugars is in the eighth. Only the position changed at the ninth. pH was in the ninth position in the first model, whereas sulfur dioxide is there. Free sulfur dioxide is there in the ninth position. pH moved to the last position here, whereas free sulfur dioxide was in the last position in the first model. So you will find very small, minute changes in the order, but whatever it is, we know from here which are the important variables which are playing an important role in the assessment of the quality of the wine. Similarly, the third method that I can try out is again for assessment of the importance of the variables. I can look at the conditional mean decrease in accuracy again using the Bremen approach. So if I have to set for the conditional mean decrease in accuracy, the same fitment, I am setting conditional equal to true. That is what will bring out the conditional mean decrease in accuracy. So let me just check what is that conditional mean decrease in the accuracy. Based on that, which variables are important and which variables are least important. The model is getting executed. Here looks like conditional is typically taking too much of a time because there are 12 different 11 different variables and various combinations are getting considered. Probably that could be the reason the conditional is not getting executed that quickly. Let me see if I can halt the process. I've closed it because it's not responding. So what I can see is I'll see if it got loaded. I don't think it would have got loaded. So going back, we can very well use all these things, right? And once we have tried out all these three different measures of testing, then we can very well talk about doing the prediction. You predict using the test sample, and we can use the predict function. See, this is not required. This is primarily going ahead in terms of seeing what is the default accuracy of the test data. By doing the same thing that we have done on the training data, we can do it on the testing data and try to see what is the accuracy of the model and what is the kappa that is associated with the model. This is purely as a base for us, the default model, what is the level of accuracy that the default model is typically generating. When I am using my predict function on the top of it, I really want to assess whether my predict function is doing a good job or not. So that's where I can very well go ahead using the predict method on the data. So wherein I will use predict fit, which is the name of our model, and I will directly take my test data and I can type in the type as response. So I'll get the response as to which class that each of these 400 odd records that are there as a part of the test data are going to belong. After that, I can do a tabulation using the table. This is where I'll get my confusion matrix, and based on the confusion matrix, I can very well assess what is the accuracy of the model and what is the level of misclassification associated with the model. So I don't think the model got saved. So let me otherwise quickly run through the stuff, right? Or otherwise I think you can very well take it through. So now that you got a basic understanding of the entire model, I want you to try it out. And in case you are not able to get through it, please let me know so that I can really help you out. Now the process after here, the process is quite pretty much straightforward. We are doing the prediction using the predict method, using our model that we have created, which is the fit, and we are also trying to use the testing data so that we can run it on the test data, and based on that we are seeing the responses, which are nothing but qualities associated with each of the 1599 minus 1119. So almost for 480 records, we have that is what is our test data size. So for all is 480 records, we are going to get through this model to which quality group they are going to belong to. Based on that, I'm going to look at the confusion matrix. So we'll get a predicted values 3, 4, 5, 6, 7, 8 kind of groups. Actuals 3, 4, 5, 6, 7, 8 kind of groups. So I will get this confusion matrix. I'm more interested only in the diagonal to look at the accuracy of the model. I'll try to sum up how many of them are there across the diagonal, which would measure the accuracy of the model. That divided by the total number of observations, which is 480, will give me the overall accuracy of the model. And from there, I can very well go ahead with a misclassification rate and talk about the error of the model. Otherwise, once this confusion matrix is created, I can use from the caret package the cross right. I can very well use that cross tabulation kind of a function to get many more details regarding the confusion matrix that we have got. We will get the kappa and other statistics associated with the model as well. So you can very well try that out and assess the goodness of fit of the model, especially when your response variable is an ordinal variable. So this is what I wanted to cover as a part of using the random forest for ordinal response variables. If you have any further queries, you can very well get in touch with me by giving me a call on the number that I have provided below, or you can even send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.